This time I will solve an example of T-beam design. This portion I already kept it here. It is from my previous video, the steps of T-beam design. My example is here. It is from your book. The reason I am solving from your book because your book did not solve the problem this way, step by step, or they use different terminology. So I am solving your book problem so that you can match it. Okay, what is this problem? There are T-beam, their center to center spacing is 10 feet, their width of the wave is 12 inch, the reinforcement will be located at 18 inch, slab thickness is 4 inch, moment due to live load is 100 kp, moment due to dead load is 80 kp. Span 20 feet, span means that way. 4 KSI concrete, 60 KSI steel. The question is design this T-beam. So design means what is the reinforcement required for this T-beam. So I kept my steps here so that we can follow. So step number 1, calculate dead load and live load. We do not need to calculate because they already gave us the moment. Calculate factored moment. So here we have some work. Calculate factored moment. So step number 1, live load, dead load, we do not need it because it is given. Calculate factored moment. Step number 2, we need it. What is that? So factored moment AMU 1.2 MD plus 1.6 ML. So if we do the factoring, I am taking the value from your book so that I can do quickly. So it is showing 256 kip feet. 256 kip feet. So this value I got from your book. I'm not doing the calculation. So I got my moment. Then is all about size. So we know this size. We do not know the size of the T-beam. So here to here. What is my size of this? We do not know the size of the B. Okay, so we will find it. How to find it? So we have 3 conditions. One is B cannot exceed 1/4 of the span. So B is span over 4. Span over 4. Span is 20 feet times 12 by 4 equals 16. So that is one condition. Other condition is B cannot exceed the center to center spacing. That is 10 feet. So other is 10 feet. That means 120 inch. Other condition is the overhanging portion here to here. This portion cannot exceed more than 8 ASF on both sides. So other condition B will be this plus 8 ASF on this side 8 ASF. So 12 inch, or if I write the equation BW plus 16 ASF, 8 this side, 8 other side. So 12 plus 16 times 4. That means 76 inch, if I am not wrong. Let me see your book. Yes, 76. So one B says 60, other B says 120, other B says 76. So what is our B? The smallest one. So B is 60. Okay, so we got our B. Write it down here. B is 60 inch. So step number 3 is done. Step number 4, assume A is ASF. ASF, that means we will assume A is 4 inch and P is 0.9. Okay, calculate AS. So how to calculate? What is our moment? 256 times 12. Why times 12? It is in kip feet. I will keep inch. So right here, kip inch. Then 0.9, or let me make some room here. Okay, or maybe delete this portion. So write it down. Our B is 16. 0.9, 60. So AMU is 256 keep feet. I multiply by 12, it become keep inch. This is KSI. So keep cancel. Everything is in inch. So I got my reinforcement 3.51. 3.51 inch square is my initial reinforcement based on this assumption. Now we will calculate the concrete compression area using this equation. So what is S? 3.51. What is yield stress? 60.5. And what is F prime C4? What is the concrete area? If I do 3.51 times 60 divided by 4 divided by 0.85, 61.94. 61.94. Okay, 61.94. Now we have to decide we are here or we are there. So calculate A. We have to calculate our A now using geometry. Okay, we'll calculate. So this portion is 60. This is 4. So 60 times 4 is 240. So obviously this area is inside my planes. If it is not clear to you, okay. This is 60 inch. This is 4 inch. So area of this is 240 inch square. This is less than this. So our A is somewhere here. So what is our A? A is simply 61.94 inch square divided by this 60. So our A is 1.03 inch. So we got our A, and A is less than A. That means this is our category. So we will delete this portion. So this is our case. Then we should calculate our revised reinforcement. That's what we will do. We will change our A, this value. Everything else is this one. Then revised A will be, if I take the value from your book or calculation, so write it down. 256 times 12, P is 0.9, then 60, then 18, 1.03 divided by 2. This time we got 3.25 inch square. Now last time we got 3.51, this time we got 3.25. Is it close? To me, no. Because there is some gap. So if it is not close, we have to find revised. If these are close, then we do not need revised. So we need to revise it. Okay, revise it. When you revise, this A should be the revised one. So 3.25, 60, then 0.85, A prime C4, B. Do not make this mistake. This B is this B, not BW. So 60. Okay, what is our revised A? Revised A, if we do the calculation, it is 0.96. Then calculate your revised reinforcement again. 256 times 12, 0.9, 60, 18 minus 0.96 by 2. And this time we got 3.25. So 3.2, we got 3.25 here, we got 3.25 here. Oh, very close except the rounding error. So our reinforcement is done. So design is almost done. Just we need to set the minimum reinforcement and phi. We will do that. Before that, make sure that you understood the sequence. So I will delete some space here. Okay. So we got our reinforcement. Then what we will do? Check minimum reinforcement and check phi. Okay, if I do quickly, what is the equation for minimum reinforcement? So 3 A prime C Fy Bw T AS minimum. Or other case is 200 Fy Bw D. So this Bw is 12. So do not make this mistake. 12. So if I take the value from your book directly, I am getting 0.68 inch square. This case, I am getting 0.72 inch square. Now we are providing more than this, so minimum reinforcement is not a problem. Solve. Next, we have to find this problem. Phi. We have to say phi. Okay, how to find phi? If I go quickly, okay, the steps are to find phi. You have to find A first, then beta 1 first, then C first, then epsilon T, then phi. If you can remember, A we found 0.96. So A is done. What is beta 1? Beta 1 is 0.85. For 4 case I concrete, I can remember it is 0.85. If you cannot remember, go back to your book, you can find it. Then C is A by beta 1. So A is 0.96 inch divided by 0.85. If I do the calculation, I am getting 1.13. Then how to find epsilon T? If you can remember, epsilon T is D minus C divided by C 0.003. If you can remember this equation from your previous chapter, so 18 minus 1.13, 1.13, 0.003. So what is this value? This value we got 0.045. 0.045. Now, then we can find phi. If you can remember, our phi value is similar to this. If this value is greater than 0.005, 0.002 something. So if our epsilon T is greater than 0.005, our phi is 0.9. What is our epsilon T here? 0.045. That is way beyond this point, somewhere here. So our phi is 0.9. Okay. So phi sec is done, minimum reinforcement sec is done. Now you need to detail. Now you need to detail. What is the detailing? Draw a bigger picture, and this portion is 12 inch, and you have to select your reinforcement here. So we need 3.25 inch square. Okay, find from your book how many reinforcing bar you will choose. So I'm going to appendix table A4. If I take 3.25, right? 3.25. 3.25. If I take 3 number 10, 3.79. 3.79 is way over design. 6 number 8 is 3.63, but lot of bars. That's not a good size. Yeah, I will choose 3 number 10. So 3 number 10. So 3 number 10 will be 3.79 inch square. Again, this is over design. If I can save some, 6 number 7, not, yeah, 6 number 7 is 3.6, number 7 is 3.61 square. Any better size? Yes, I do not find any better size. Or we can do combination. Combination means some bar this, some bar say number 10, some bar number 8. But laborers will not like it. That is difficult for estimation, construction this way. So yes, I will choose 3 number 10. Oh, even this is better. I will choose this one. 6 number 9. I have 12 inch, so I have to leave some space for cover. So what I will do, I can do this 3 bar here, 3 bar here. Yes, if we do 3 then should be good. So 6 number 9 bar. Yes. So I will bundle it because I do not have so many space here. I need to leave some space, say 2.5 inch here, 2.5 inch here. Then I need to leave some space. Then you can finish your detailing. To give some tie bar, and your slab will have some reinforcement too. You have to combine both your slab reinforcement and beam reinforcement. That is our next discussion. At least for this T-beam design, make sure that so 6 number 9. This should be number 3. Okay, so this portion should be good for now. Okay, so I solved one example. In my next video, I will solve another example. Thank you.